As Mark said, my name is Jacob Perry. I'm the lead engineer here at RCN Technology. So just so we're all on the same page, we're just going to take a quick 5 minutes and go over kind of the basics of 5G, and so that way you have a good basis for what we're going to be talking about today. So first and foremost, 5G is separated into three flavors or three layers. Basically, three different types that do varying different things and are useful for very different things. At the bottom, we have the low band 5G. That's everything in the sub 2 gigahertz category. So this is an excellent graphic that you guys provided to us that shows the coverage layer. And I like that term for it because low band goes the farthest. It has a lower capacity. It may not be as fast, but it can definitely cover a wide range. So in the middle, we have the mid-band space between the 2 and 6 gigahertz, also known as the sub-6 category, where we're going to see some of that speed and some of that latency that we're going to get whenever we get up to the high capacity. But we're still not going to have as short of range as the high capacity is going to cause us. So we can get a little bit farther with it, not as far as the low band. And it's going to provide us with a little bit more capacity and a little bit more speed. And so then we get up to the high band or millimeter wave, which is 24 gigahertz and above, has a very high capacity, low propagation, which means that it doesn't go very far and it doesn't penetrate layers very easily. So we're going to see it in a shorter range in smaller, more dense areas. But it's still really, really exciting. David, did you have anything to add on this slide?
Yeah. So another great thing that this slide shows, I mean, while it shows the propagation of the signals and how the coverage layer goes vastly farther than like the high band and high capacity layer, it also kind of illustrates a little subtly in the background the penetration of these technologies. So your sub 2, your low band 5G sub 2 gigahertz, it's going to really penetrate most buildings, most surfaces pretty well and get signal indoors. Whereas when you're talking about high band and your millimeter wave, you're really not getting much penetration into anything. Like it's more direct line of sight. You have to have an antenna pointed towards the tower, that kind of thing. So a little trickery in the image that kind of shows another difference of the capabilities of those bands.
Absolutely, that's great. I love that this graphic shows that so well. So next up, we have another really great graphic that shows kind of the range that each one of these three different flavors are going to live in. And as we went on before, high capacity, high band, we're going to see a small, very dense area with more cells needed to carry it farther because of that penetration issue. Whereas in the mid band, it's not going to go as far as the low band, but we are going to be able to move it with less cells and be able to cover a pretty dense area, even still with it. And then, of course, the benefit of low band, seeing how much we're actually going to be able to expand outward and go further away from the point, but also using less cells to do so. David, did you want to add anything here?
I mean, really, the only things really to add, I mean, that's a great overview of what the slide depicts, but it also gives a couple of, simple use cases of what you might find that fall under these band categories. The simple wireless augmentation of SD-WAN, your regular wireless failover in the coverage layer area, because that's where you just need the connectivity, but don't necessarily need the throughput or need the ultra low latency. And then as you really start getting into the middle of the high capacity, where you have the augmented reality and the AI video recognition and that kind of stuff, where you really need that speed and throughput as well as that low latency for that connectivity.
Yeah, I love all the little use cases we see from public sector all the way to wind turbines. A lot of things we may not think about needing connectivity in small ways, but they definitely do.
Yep.
So another very similar graphic. We involved this one as well because I think it shows a lot better the amount of towers, that density we were talking about earlier, along with giving a few more examples of different ways we're going to be able to see this. And I like I like showing, the machine recognition and triggers and wireless robotics and that sort of thing in the high band space, showing that these are machines that we're going to have a lot of them running all at once, and they're all going to need to be connected and have really low latency and good capacity.
Yeah. And that's where that dense scale comes in with that millimeter wave, being able to support that many devices, that many connections. Albeit you have a lot more towers, depicted in the orange on here, a lot more towers for such a small coverage area, but you need that because that lack of penetration and just the signal doesn't propagate well. Whereas as you move out into, I know it's not showing the coverage where we're saying capacity and coverage layer and all that, but you can kind of get that from the 4G gigabit class being your coverage area, how you only have a couple towers that cover that enormous area and range.
Yeah, and I didn't even touch on how this is showing the gigabit class LTE, which I hope we get into a little bit today. Definitely, I think a topic that kind of gets pushed to the wayside a little too often.
Yeah, it generally does. I mean, especially with a lot of the hype that's come out, with 5G, just a lot of the spark over the past year and a half that 5G is coming and it's going to have all these great benefits and capabilities, but you really can't undercut what's available today and really what we have in the marketplace already, even with some limitations with the 5G.
I couldn't agree more. Yeah. All right, and then here we just see some few statistics. Really like showing those visual graphics before getting into a lot of numbers. But here we see the vast difference in speed, and that this is more of a guideline, more of a top speed of what you're going to be capable of seeing, maybe not always what you're going to see. And so the coverage layer, that 4G LTE, 60 to 100, even in today's world, is still nothing to sneeze at. Most businesses can run on 60 to 100 perfectly fine and be very stable. But of course, we see a little bit worse latency, which is where 5G comes in. With that 8 to 12 millisecond latency, of course, a lot better speeds. But once again, we need more solutions that are going to be able to utilize those high speeds. And in today's world, we don't see it too much, depending on the use case. But that latency is going to change a lot of things going forward. And then, of course, going into the high capacity layer, we see a very large climb in speed, can get up to even 3 gigabytes a second, and theoretically even higher. But we still see that latency around the same range as the midband, which is the really important part.
Yeah, absolutely. Absolutely.
All right, and then the last thing about 5G is slicing, which is in itself just a utilization of software-defined networking, something we've had for a while, but we're being able to kind of build these infrastructures from the ground up and be able to do it with everything we've learned from LTE, and make it way more efficient, a lot more manageable. And then, of course, for the namesake, slicing, being able to section off individual portions of networks for particular companies, particular businesses, and also seeing a lot more viability for a lot of private cellular. Anything else to add there, David, on slicing?
Yeah, I'm not too much. I mean, slicing, it's going to bring security because you can segment your different slices and your different the core pieces of the technology. But it's also a way that 5G really gets to that connection count, gets to that high number of connected available clients. And that's one of I think one of the earliest developments of the 5G that we'll start realizing before a lot of the other things is what that slicing will bring us.
I also couldn't agree more. I'm very excited to see how these capabilities are going to affect infrastructures and businesses, and how this is going to do everything going forward. And excited to talk about how to position yourself for it.
Yeah.
So
Cool.
I suppose we can jump right into it. That's the end of our overview.
I guess to start, I mean, like, what do you guys see as the future of 5G? I know you love that question, Jacob, but yeah, what are we thinking?
Yeah, I can definitely lose myself in conversations, and and in kind of ranting about what 5G is possibly going to bring us, not necessarily what it has just yet, but the abilities that it unlocks are going to be so great. David, I would actually love to hear what you have to say about that.
So, I mean, it's a tough question to really answer, right? What's going to be the 5G of the future, and how's the future going to come out? I mean, it's really one of those, if you can think it's going to be possible with 5G, right? I mean, think about how LTE and 4G, when it was originally deployed, no one knew, exactly what we were going to gain and what we were going to benefit from it. But now we have Ubers, we have self-driving cars, we have all these technologies that developed because of the 4G technology, as it was rolled out and as it improved and advanced over the years. I mean, the sky's really the limit, at this point, with some of the capabilities that 5G is potentially going to bring us. Yeah, if you can dream it, you can make it a reality, I think.
I couldn't agree more. I think I love the phrase, if you can dream it, it's going to be possible. And that's so true for 5G, because that's why we can kind of lose ourselves in futurescaping 5G and what it's going to be capable of, because there's so many limiters out there to the technology we have today that I think a lot of people aren't aware of, and tons of those limitations when it comes to latency, internet anywhere without the need of a cable, and really as small as you want to make it. These are all things that are going to unlock a Pandora's box of possibilities in our world.
Yeah, I agree completely.
Yeah, that's awesome. So I guess to go the other direction, so from whenever we first started hearing about 5G, which I honestly can't even remember when that conversation started, but what has changed, like as far as your specific focuses in your roles, right? So like from just hearing about 5G to where we are now, to where you think you are going to be going with 5G.
So, I mean, I'll kick this one off, Jacob. For a change. So I first started hearing about 5G. We're gonna call it 2017, right? Is around when I really started seeing glimpses. I know 5G has been talked about, 2013, 2014, and that's when they really started building the spec for it and everything, right? But I really started getting interested and understanding it around 2017, 2018. Back when I was just really gun-ho into LTE and seeing everything that it's driven us and what it's brought us and its capabilities that not everyone even at that time was benefiting from and really leveraging, right? So, back then it was, what can I do with this technology? Today it's what can't I do with it? Where am I going to hit that limit? What can I push it to? Where for lack of a better terms, where will I break it? Is really what I come down to now. But I mean, as far as what I do today, 5G's only enhanced my love for cellular technologies. I have to say that right off the bat, just because I just love the ever evolving nature of the technology, and the new things that we learn almost on a quarterly basis. Even with 4G, as 4G Advanced Pro was being rolled out and everything, that was what, 2 years ago, not even 2 years ago. Still learning, still evolving and developing. So, yeah.
Yeah, I around the same time probably heard about it, and I'd say I had a similar reaction. I think from the get-go, maybe not as much back in that 2013, 2014 era, but coming forward to 2017, 2018, it was a lot of hype surrounding something that I think in the positions we were in, we knew wasn't quite here yet. And because it wasn't here, it was hard for us to determine what it was going to do for us. How was it going to be different from LTE? Just a little bit faster, not? And even still going into that, I think so many people talked about how, oh, it's faster, it has better latency. And that's pretty much the only thing we heard about in the beginning. And I said, okay, that's better, that's cool. But I don't really see how that's going to revolutionize us. And then more and more started coming out on it with the backends and what's really going to be capable with it. And I completely agree with what you said, how it's only 5G and it's coming about has only greatened my love for this field of work and greatened my love for cellular technology, and has led me down paths of education and understanding into this that I didn't expect to go down in my career, because these are things we now have to adjust to and learn. And you know, seeing something on the forefront that could absolutely revolutionize all technology across our planet, and being able to be a part of that in a small way near the beginning, is something really special, I think.
Absolutely.
Yeah.
Yeah. So another one, and this is one that I had on my list, but it's also one that we had a few people vote on the polls as well. So what would you say to someone who is maybe preparing their organization for 5G, or if they're not even at that stage yet, right? They're just still in the learning phase. Like, what are some of the benefits that they're going to see? And obviously that's going to be so different across different verticals, but I mean, what can you guys say to that sort of question, I suppose?
David, I'd actually love for you to kick us off on that, being a little closer to the source on that subject.
Yeah. So, I mean, looking forward towards 5G and what to expect, it's really going to depend on what the needs of your organization are, right? Are you going to need that ultra high speed? Do you need that ultra low latency? You know, are you in augmented reality? Do you have, robotics that you need to have real time communications with? Or do you really need that coverage layer? Do you really just need that always on connection that doesn't go down, that's going to give you the penetration? And it really makes you look at your organization and say, okay, what do I need? And in reality, it might be a mix of a couple of facets of the technology for the same company. You're like your POS and your retail organization, they don't need high speed, they just need always on connectivity. Whereas all your little IoT sensors and beaconing and stuff like that, they kind of need that quick talking capability to be able to present, ads to somebody, or to be able to provide metrics and analytics in that organization. So you have kind of a mix of what you're going to be looking for, and that's kind of what you need to look at as organization as a whole. Now, I mean, 5G comes with a lot wrapped around it. There's a lot of, as you mentioned, Jacob, there's a lot of hype with it, right? There's a lot of talk about everything 5G and that you need it and you want it today. But in some cases, that might not necessarily be the case. In others, it might be. I just give you a quick example. We one of our first deployments was down in Australia, a company called Taylor Construction, on Telstra's network, and they wanted to redefine how they do development and construction practices as they're at their job sites. They're bringing in these 8K cameras so that they can show, monitor the safety of the environment, make sure their employees are acting in a safe manner, make sure they're following proper safety protocols and stuff. And 8K needs a good bit of bandwidth, right? But then turn that around, they're placing sensors in the rebar of the construction of the concrete that they're pouring, so that they can monitor to make sure that the concrete was first poured correctly, but also they can monitor the concrete over time to see if there's any movements, any cracking, any shifting, any breakdown in the technology. So it's some more of that IoT side of the 5G that really benefits them. And then finally, going back more towards that higher bandwidth, but then needing that lower latency, is they're doing real-time design change and display, right? So they have these blueprints, and they are massive files, blueprints of buildings, blueprints of floor plans and stuff like that. They're able to change them on the fly and ship them over to tablets of people on site at those locations right there. And they're pulled up in a matter of seconds. So it really, really awesome use case. And I think it covers a good breadth of what 5G today can deliver. So yeah, I can only imagine, like we said before, I can only imagine what the future has in for it.
Absolutely. And I agree. That's such a good, I almost don't want to say starting point, but that's such a good implementation of what 5G can do for you today, where they have such high demands and a need for, no misses. They can't delay. and dealing with those large files, dealing with so many endpoints. Such a good example of what 5G is capable of. I would definitely carry on that line of don't be afraid to look into whether or not you don't need 5G today, because I would say majority of businesses don't, because LTE is still in a great place and really at the same rate that 5G is ramping up. LTE isn't being forgotten about, and it's only being improved, and it's not going to go away for a very long time. So I think the mentality of switching from 3G to 4G, it was such a drastic change. That there was a lot of features that we had to leave behind in 3G in order to carry on. And I think 5G is going to get to that point for sure. I just don't think it's today. And I think a lot of people can get away with, gigabit class LTE or even just regular LTE for, like you said, your POS systems. For the 5G, I would actually invite people to imagine more often. I would invite business owners and network administrators for companies to imagine what your business does and what it could be capable of with certain technologies. Even though you may only be an office building, everybody just uses computers to send emails, to make sales. Take a look around your building and say, what is my security system running off of? What are my door sensors running off of, or badge scanners? A lot of times it's all cabling back to a central system, and that's one use case where we see a lot of endpoints that we don't want to see a lot of latency, especially in an emergency situation, that 5G can be capable of. And that's just a small example of kind of a way to think outside the box of what your company's doing today and how 5G can change it. Because I think there's a ton of creative ways, like you said earlier, David. If you can imagine it, it's kind of possible with this technology.
Yeah, and it definitely will be. And I mean, one thing we really, I guess we didn't really touch on at all, and this goes to your Gigabit LTE still being enough today, is kind of the back-end architecture of 5G, right? You have a difference between a non-standalone architecture and a standalone architecture, where the non-standalone architecture still needs that anchor band that's going to be provided by LTE, provided by that 4G. And that's really what most everyone is deploying today, right? That's what the carriers in the US here is deploying today. Whereas with the example that I had from Taylor Construction, Telstra, they don't really have that anchor band necessarily. They have a standalone 5G network that's able to afford them a lot more of these lower latencies and these higher speed capabilities that are available there. Now, one thing that we are doing in the States by having this non-standalone architecture is we do have 4G and 5G running synonymously, running at the same time. And as more and more devices, my iPhone, the Samsung devices, as more and more of these devices start getting this 5G capability and connecting to the 5G side of the towers, and we start breaking apart these towers from the standalone into hybrid standalone, non-standalone, that kind of architecture, some of the burden off the LTE, off the 4G side will be lifted and moved to the 5G. That'll open up that LTE band. So that'll make your gigabit you already have in place today seem like it just got a boost of speed, seem like it just jumped up in performance, whereas all that happened is some of the stuff that's everyday use is being moved to this other 5G. Now, it's not to undercut and say that 5G is going to start getting throttled, it's going to be a burden on the 5G, I'm going to start slowing down and stuff. That's not to say that at all. It just, as they start slowly making the shift, it's going to start, we're going to see a dynamic change. And we already see it a little bit today with T-Mobile and their network. They're focusing pretty heavily on 5G as it is. They're actually taking little pieces of their 4G slices and giving it to 5G to make their 5G that much better. Whereas they're still providing enough capability on their 4G network to support what is already present and already out there.
Yeah, and I would argue to that line of offloading some of that load that really has just been building up over the years, which kind of gets into how we didn't know how LTE was actually going to affect us going into it. Like you said, now we have Uber and smartphones that are more capable of any computer that we had just 5 years ago. And really, that's all thanks to LTE technology. And so its load just has kept getting heavier and heavier as we wanted to do more things with it. And so offloading it to the 5G, I think the argument is made that 5G is more capable of taking that load because of the back end that's being developed, the 5G cores, if you will, which is something that I'm really excited about. The more I read into it, I'm sure you've done plenty of reading on it. It's quite the rabbit hole to start going into the infrastructures and what the carriers are doing today to build these infrastructures and how they're going to affect everything on a massive level. And so it's going to be a lot more capable and a lot easier to shift things around whenever you're offloading that 4G over to it. But I've never thought about how 4G is going to have less or less stress on it once they start doing that and really start doing it in full force. That's an excellent point.
Yep.
Yeah. So
yeah. I was going to ask real quick. Can you guys? You briefly mentioned the networks. Can you guys speak to kind of what, as far as you know, like the networks are doing, what kind of the state of that looks like?
I'd say a little bit, mostly what you can read about online about what's going on. A lot of resources out there to go deep into, but I think a lot of it is definitely a little bit gated the deeper you get on how complicated of an information it's giving you when it could really be simplified, which is. So software-defined networking, slicing, all of these things are based off of that backend, how we're building it, how the carriers are building it, and they're basically building a network from the ground up that's capable of handling what we weren't really capable of handling with LTE. I just saw a diagram a couple of days ago from a company who just reworked their backend, and they said this is what it used to look like, and this is what it looks like now. And what it used to look like was just a diagram of a kind of a spider web, honestly, where you could tell it just kept getting piecemealed, and we don't have enough bandwidth for this. We don't have enough capacity to hold this many clients, and these clients are going in the wrong direction. So we need to put this here, add this there, and eventually you kind of ended up with this beast that was difficult to manage. And with the 5G networks, building it from the ground up and having a better understanding of what kind of capacity it's going to need, their rework frame rate was, it looked like a geographical or a geometric work of art, seeing everything in its correct places and knowing exactly how everything's being routed, how everything's moving across it. And of course, one of the biggest changes is being able to change it on the fly. I don't know, David, how much reading have you done on the changes aren't going to be physical? We're not going to need to have someone on site to add another firewall or add another machine or to do this or do that. We can instead shift resources on the fly with 5G.
Yeah, and that comes in from that SDN, right? The software-defined networking. That's kind of inherent in the core of 5G. Being able to shift resources to towers that need it, or being able to shift frequencies as they need to because something's getting bogged down because of interference in an area or something like that. It's a lot of back-end technology, and again, we can really get into the weeds with this if we're not too careful with it. But so I mean, carriers, they've really been working with 5G in mind, over the past handful of years. You see the likes of Verizon and AT&T constantly updating the towers that they have out there. They're updating the back end infrastructure, the backbones that they already have, because while your phone might be capable of sending a gigabit a second, it's got to get out to the internet somewhere, right? That tower, it's not just a blink for the tower, but you have a mixed bag at the towers, right? The carriers thought the best way that they were going to be able to carry this data was going to be over fiber. So they started loading up these towers with all these fiber runs and all these fiber cables. And then as they developed the 5G spec more, they're like, well, wait a minute. I have this millimeter wave and I can see that tower over there. So I'm going to use my own technology to ship my stuff all around to my network backend to then get it out the way that I want it to. So the carriers, in a way, are building the network for the consumer, but also for themselves to be able to leverage as well. And to go with your kind of spider web, your spider web depiction and what you saw in that picture there, I imagine that when 4G was rolled out, it was that nice, pretty diagram originally, and then
Absolutely.
as they developed it and as things changed over time is when you started getting the guys that are just ripping and replacing cables and making things into that rat nest that they basically changed into something new that's pretty. And I'd be interested to see what that looks like in 5, 10, 20 years to see how it's changed or how it's evolved. But I'll bet it takes longer, like I say, 20 years. I bet it takes longer to get to that point because of all these software defined capabilities that we have to be able to make changes on the fly, like you say, and not have to rely on someone to physically move a cable here, someone physically install boxes here and there, you know. So yeah.
Yeah, I completely agree. And you could kind of see remnants of probably what it used to look like, and it was more just straight lines of box here, line there, box here, and then sort of row those out in parallels. Whereas with the new infrastructure, you see a lot of crossing and like we're talking about, that ability to move resources on the fly rather than moving a cable. Is going to be extremely key, and I couldn't agree more that I think we think we have a good understanding of what 5G is going to require today, and I agree that we also thought we had a good understanding of what LTE was going to require 20 years ago. But because of that being able to shift, I didn't expect this suburb to grow to 30 houses. Whenever we installed this tower, only 3 houses were there. Now we have to go in and just keep adding, keep adding, keep adding. Whereas with 5G, we're going to be able to see, in the last 10 years, Tower One's community around it has grown X amount, so we can shift our resources from our office at our computers from this tower to this tower on the spot. And it may grow to a point where we might need to add things, but I think we're going to add it a lot slower. It's going to hit a point where we're going to say, okay, maybe we need to add one more box here, but that might not be 5 or 10 years down the line.
Yeah, and it could be that they're adding boxes because the technology's advanced, because the technology's changed. So we need to physically make a shift in something in order to make it work. And your example of the small community that then kind of blossomed and grew really quick, that comes into play with that carriers using their own technology to carry their technology, right? So that millimeter wave that can go, tens of gigabits a second at ultra low latency speeds, half a millisecond, 2 milliseconds latency speeds, is carrying that data to where it needs to be, rather than, okay, I need to grow this tower to support these customers. I can just shift the data that much quicker, that fast, that I don't need to make those resource changes physically. So absolutely.
Absolutely. So
go ahead.
Oh, go ahead, Mark.
I was gonna say just one more question I got in this segment, and then we'll move it on to Q&A. But what is your favorite thing about 5G, whether it's something that's here now or something that's going to be coming?
What isn't my favorite thing about it? I think it was that statement we made earlier. Your imagination is going to become your own limitation for this technology. Once speaking of going deep into the weeds, we can go into augmented reality construction sites. We can go into augmented reality arcades or VR arcades. We can go into how it's going to affect amusement parks, how it's going to affect the public sector with internet ingrained helmets and perhaps a firefighter's helmet that allows him to see real-time temperature checks of the room around him as he's walking through it. This technology quickly starts to unfold into the future that we all saw in the movies 20 or 30 years ago and was really excited about. And I truly believe that this technology is going to be a really important stepping stone to getting us to that really exciting futuristic sci-fi reality with time.
I think I'm going to go a slightly different route with that and say I can game that much better. That sub millisecond ping I'm going to have is going to make me that much better of a player. No, really. So it does kind of come around with that, right? But the ultra low latency is probably one of my that's probably one of my favorite aspects of 5G. Just being able to get that, we'll call it instantaneous connection, with anything and everything. And then when you couple it with the speed, I'm my most exciting part of 5G is what it's going to bring us in the next 5 to 7 years. Like what technology is going to be derived from it that I can't think about, and most of us haven't thought about today. What's going to come out of it is probably my biggest thing, along with all the learning involved, because I absolutely love learning new things, and there's endless resources for learning about 5G just because of how in-depth and how much there is about it.
Yeah, I also love learning so much about it, and I love that what I think it makes me want to change my answer. The most exciting thing that we're going to see is the thing that we can't name right now, the thing we're not imagining right now, that someone somewhere is going to imagine, and it's going to completely change maybe one way we do business, maybe one way we do safety, or maybe the entire world as a whole. We really don't know yet, but I agree that there's going to be one, if not a few, if not a lot of things that we're not even thinking of right now that it's going to affect.